Hello, pre-calculus student. This video is for chapter 3.8, part 2. So we are looking at inverse of radical functions. So why are we talking about radical function? This chapter is for polynomial because actually the inverse of a polynomial function is a radical function. So we did that in the last video. If we want to reverse a polynomial function, we'll take roots. So they become radical function. So we'll just follow on to talk about radical function. If we are to find the inverse of it, of course, it will become a polynomial function, right? So that's what this is about. They are the inverse of each other. If you inverse a radical function, it become a polynomial function. And now because the what happened is when you look at radical functions, they are if it is a even with function, they have the domain. So the function that you implement will have the polynomial function that you implement would have a range that is different from an ordinary polynomial function. So we're going to talk about it. The process of finding it is really similar to what you have. You usually graph your function to make sure you know the domain and range, and then the domain. Actually, you graph it so you know that the range of the original function, and that would be the domain of your inverse function. Okay, so because ordinarily speaking, a polynomial function has real number as its domain, but if you are using getting that inverse function from a even root, you have a restrict domain. So for example, the first, find the inverse of square root of 6x minus x plus 5. I think I did part of it in the last video, but I'll redo it again because I don't think I finished it. So first we do the swing and swatch. Well, actually, we can kind of figure out what this function is about in terms of the domain and range, right? So the domain of a radical function is, so we do it here. The domain is the inside is greater than or equal to 0. So the x would be greater than or equal to 8 over 6. And then if I graph it, so this is a square root function shift and then up 5. So the range of it is what? So it has a starting point of x is greater than 8 over 6. Starting from here, 8 over 6. And then up 5, right? So the range of this function, so we can actually do a domain. Domain is x greater than 8 over 6. Range would be greater than 5, right? Y is greater than or equal to 5. So this would become the inverse function's domain, and this will be the inverse function's range. So, but let's find it. Y equal to square root of 6x minus 8 plus 5. So in order to do the inverse, we switch, which is 6y minus 8 plus 5. And then we want to solve for y. Solve for y. So x minus 5, get rid of the 5 first, equal to 6y minus 8. So to solve for y, we need to get rid of the roots, so it becomes x minus 5 squared equal to 6y minus 8. And I think I did that also in the last video. And we plus 8 on both sides, so this would be x minus 5 squared equal to 6y minus 8. And then plus 8 plus 8. Oh, this is a minus 8, but plus 8 on both sides. So, and then divided by 6, you can imagine it would be x minus 5 squared plus 8, and then divided by 6. And that is the inverse function. Go to x minus 5 squared plus 8 divided by 6 with a domain of what? X is greater than or equal to 5 because that's what was the range. And the range was the domain. Y is greater than or equal to 8 over 6. So it is not a regular kind of polynomial function, but with restricted domain. Now for the next one, it is find the inverse of a cube root function. The cube root function has all real number, so we don't have to do any restricted domain. So it's really easy. You just say y equal to 3 minus 4 cube root of x, and you switch x is equal to 3 minus 4 cube root of y. So step 1, write as y. Step 2, switch x and y. Step 3, solve y, right? Solve for y equal. So how do I solve for y equal? I minus 3 first. X minus 3 equal to negative 4. So don't forget the negative. Cube root of y. And then I do divided by negative 4. X minus 3 divided by negative 4 equal to cube root of y. Now I can get rid of it by writing y is by cube on both sides. X minus 3 over negative 4 cube. Right? So that is it. So I would say f of inverse of x of this function is x minus 3 over negative 4, the whole thing, okay, not just the top cube. And the remaining range are all real number. Okay. So the last part is inverse of rational function. We briefly talk over this in chapter 1. The last part of chapter 1, but we don't get into like more complex rational function. Before we start chapter 4, actually we will do rational functions, but so we're dealing with inverse of rational functions. The way we do it is the same. You rewrite x and y. You rewrite y as f of x. You interchange it and you solve them. But they're a little tricky because y would shows up in different place after you replace x and y, because you have x on both numerator and denominator. So first is x minus 1 over x plus 2. So just write step 1. Step 2 is switch x and y. So x is on the left-hand side now, and I have y minus 1 over y plus 2. So this third one is to solve for y, which is quite difficult because you have 2y. So you have to multiply clear denominator by multiplying y plus 2 on both sides. So x times y plus 2 equal to y minus 1. Because if you multiply y plus 2 on this side, this cancel, and this would have y plus 2. So then you multiply it out, xy plus 2x equal to y minus 1. So there's y on both sides, so we want to switch minus 2x, minus 2x, minus y, minus y. So on this side we have xy minus y, and on the other side we have negative 1 minus 2x. So then we factor it out. Factor the y out will be x minus 1 equal to negative 1 minus 2x. Y would equal to negative 1 minus 2x over x minus 1 after you divide it. So the key thing is you factor the y out so you can divide it. So that's how you find inverse of rational function. Applications. So we have two do I have two applications? I have two applications here. Hopefully I have enough time. So the first is about the vertical movement. Remember, we say vertical movement is affected by gravity, which is negative 16t squared, and where you are, right? So the object is drop. So drop means there's no force applied to it to change its motion. So all it has is affected by the gravity and where it is in the beginning. So in the beginning, it was at 500 feet, so you have 500 and then subtract the gravity. So this is a model for our object's vertical motion. Express t as a function of h and find the time to reach a height of 200. So suppose you want to find time equal to something when height is 200. So of course you can plug it in and solve for it, but if we can have a function like this, that would be nice. So the way to do it is you want to do t equal, so we'll use the inverse. So we write y equal to 500t, or 500 minus 16t squared, and then we actually just solve for t. You don't have to change x and y. So, well, actually I should say h, right? Instead of h of t, we just use the word h. h minus 500 is equal to negative 16t squared. So to solve for t, I eventually need to do square root. So I need to divide by negative 16 here, so it will be t squared. Now we're ready to do square root. So the square root of h minus 500 over negative 16 is time. Okay, it's the positive. So, and of course, because you're dropping from 500, your h would always be um, less than, greater than 0, but less than 500. So this is a less than 500 and also cannot be 0. So this is the domain, and our restricted domain would be h would be less than 500 because you do not want you just switch it around. You can do 500 minus h over 16 because there's a negative here is rather uncomfortable. So h is less than 500. And so this would be your function. You can say function of t is equal to 500 minus h, or function of h, it should be. This is a t function. I should not use h, 16. So if the height is 200, so you would say t equal to what? So that would be, I should not, this is h. I would be square root of 500 minus 200. 500 minus 200 over 16. So that would be, what do you have? 500 minus 200 is 300, 300 over 16. So that would be t. So it's nice to have a function to plug in instead of solving it every time. So just put in the calculator square root of 300 divided by 16, 4.3 for 1 decimal place. Second. So let's do the second example is a pendulum. So the time that pendulums, like the period where it swing is depending on the length, right? The longer the pendulum is, the larger the time it takes to complete one period. And it turns out that it doesn't matter you start from earlier or later, the time period is actually the same. It only depends on the length. You can try. Determine the length of a pendulum that can achieve a period of 3. So that means I know the time, but I want to find the length. So let's find the inverse function. Okay, so this will be L. Oh, okay, so it would be T is equal to 2 pi. So we get rid of the function notation, just use a variable, 32.2. So in order to find length, so I want to solve for L, right? To solve for L, I just do t over 2 pi, get rid of everything that outside of the radical first. That'll be square root of L over 32.2. Get rid of it, we've squared both sides. T over 2 pi square would equal to L over 32.2 because when you square both sides, the root cancel. And then how do I get rid of the 32.2? I multiply it. So basically t over 2 pi, square it, and then times 32.2, you get you the length. So this is the length formula that you can calculate if you know t. So when t is 3, the period is 3, then L would equal to 3 over 2 pi, square it, times 32.2. So let's see what it is. The calculator, so it'll be 3 over 2 pi, full time pi, no, 3 over 2 times pi. Okay, and then square this whole thing, and then times 32.2. So I got 7.34. Is it a meter or feet? 7.34. I wonder what the length is. They didn't say. I think feet, I think. Okay, so that's all for the inverse function, chapter 3.8.